So many of you, really all of you, are already familiar with Crane. It is it's a unique tool, and its mission is to make GHG modeling publicly available, globally available to everybody who needs it, while really trying to contribute to the digital, we say, constellation of organizations and people working on real climate solutions. So it's a key kind of nexus point, and sometimes it's just a conversation starter. Ultimately, we're trying to reduce the time and resources required by you all and those in your fields, investors, entrepreneurs, government agencies, you name it. Trying to reduce those requirements when doing this type of analysis, which is itself new. It's an emerging field. So, with respect, if you want to go to the next slide, Aurora, with respect to the history behind it, we've been at this for a while. 2018, we had our early methodology guidance come out. This was before Rho Impact was involved. Prime came out with a document co-written by NYSERDA, laying out how to do emissions reduction, a framework for doing emissions reduction potential assessment. That was kind of a phase one of their work, and then phase two was turning it into software. And that's where, at the time, our organization was Rho AI. Rho Impact is a spin out of Rho AI. So if you see Rho AI around, that's us. We partnered up with a few other firms and managed to receive funding from the MacArthur Foundation, the state of New York through NYSERDA, Massachusetts Clean Energy Center, and direct funding from organizations for which we will forever be grateful in order to build out the first version of Crane. So by the end of 2019, we had a prototype and a good bit of data to put in the tool. Also, quick shout out to Cassie, who's been here from the beginning. Like the very first Crane code was authored by her. And by April 2020, we released the beta version. It was Crane, and sort of inauspicious timing of the start. But in that time, we've seen the user base grow from 40 people to 4,000, and it continues to grow. And that's very organic growth. And I'd also say the Frame has designed, Project Frame got onto its feet and has released a number of new resources. If you want to go to the next slide. So what's new? What are some of the concepts that you're going to see in the new tool that are worth mentioning here directly here at the beginning? One is just kind of level setting. We've refined the user experience quite a lot. I'll just mention this before talking about what's on the slide. Access to data is a key thing, a key focus area for us. Really practical transparency, being able to download the right things at the right time so that you can work them into your own workflow. Really unlocking what's already in Crane has been a big point of conversation, and then streamlining the process in a way that didn't have folks feeling like they were getting in their own way, or that the tool was getting in the way of their workflow. The other major thing is Project Frame guidance alignment. That includes terminological changes such as planned versus potential, which addresses the scope of the analysis, planned being for an individual company, and potential being more around the technology category. As well as order of operations, which is not a trivial point from, as you all know, from a science communication standpoint. So now we're really focused on per unit impact, and then understanding how that relates to the the market penetration. Or if you want to go to the next slide. So we've got more traditional or more conventional naming of our markets, as well as I don't want to steal anybody's thunder here, as well as some really cool other features related to S curves and finding the relevant technologies and so forth. So there's a lot in store for this. You'll see a lot of changes. Some of the things will look similar, sort of aesthetically, but under the hood, there's quite a bit going on. So with that, I'll turn it over to Aurora, who's going to take us through the demo slides.
Awesome. Thanks, Seth. I am going to take you through the demo slides, but first I'll just show you in the tool how you get to the main page, because sometimes there's a bit of confusion over that. So if you go to cranetool.org, you go to Crane login, and from there, the landing page now should be the new impact assessment. But if you're not seeing that, you click on the 3 bars and go to impact assessment. And this is the new landing page for the tool. You'll see over here, it says deprecated Crane beta tools. These are Crane as you knew it before that will be deprecated by April to the public. So this will be the new version of the tool going forward. And you start by searching for your technology of interest. So if I'm searching for cement, you can see all the models that we have relating to cement come up. And in this demo, I'll select clinker production, which would take us to the first page here. So let me go through. I have slides with tips for each different page. So if we go to clinker production, well, first, if you don't see your technology, this is the short answer for now is choose a related technology that you think will have similar GHG data or market data that you can utilize, and you can modify the values later. We'll also have more options for building out your custom models in the forthcoming months. So once you select clinker production, you'll be on the screen for setting your units. And in this instance, we're going to set the units of the time frame that will do the analysis. So it's recommended if you're doing planned impact to not go past 2030 or 2035. So let's say here we'll do 2035. Even for potential impact, obviously shorter time scales have less uncertainty. So there's a preference there. Obviously, some people go out to 2050. And then you can select your sales unit. This has been an improvement upon the previous version where you were constrained to whatever unit the model was defined in. Now we have a lot of back-end conversions, so you can select the sales unit that most closely aligns with what you already have data for. So in this case, we're selecting megatons of cement. And then the incumbent market in this instance will be cement production globally. Now, this is limited to whatever data sets were entered for the default models. You can select, you can just select one and then modify it later. If, say, you didn't want global production, but you wanted production in China, you could then enter the values for China on the following screen. I also want to call out here that you can skip directly to the results by clicking at the bottom. Some people just want to explore the data we have for each solution, and the easiest way to do that will be skipping to results. You can also kind of get a sense of where this is going and then press back and go and enter everything once you have an idea of what the final page will look like. One other thing to call out is right now, you can't see the solution description on this page that is coming shortly, but if once you access the tool, you're not seeing this yet, just because it's still in dev, you can go to the results to read about the solution and then come back here. So the next page is your incumbent market emissions, and this is going to be your baseline GHG intensity. In this case, it's global cement production, and you can see the references that were used to obtain these values. If you go to edit reference, it will show you the references. You can also delete them or add your own. So if you start changing the values, that would be the recommendation, and they'll appear in the report. And then you can also see a graph of your incumbent unit emissions over time, change interpolation methods if you, say, only have 2 data points and don't want to do point-to-point interpolation because you expect some kind of other trend as time goes on. I also want to call out the units here. We have decided to go with SI units for everything except for carbon dioxide equivalents because the financial reporting uses million metric CO2 equivalents as MMT so frequently. We're sticking with that, but everything else is SI. So if you see capital M, lowercase t, megaton, and that was written out with the full unit as well on the prior screen. But here, this would be million metric tons carbon dioxide equivalents per megaton of cement. And this is the baseline intensity. And then the next page is your solution emissions. And in this case, these were taken from a paper that was looking at reduced emissions clinker production, and they found a 30% reduction. So the person who developed this data set used that 30% reduction to define the solution unit emissions. We previously had it where you were defining the uncertainty for the entire model, but the challenge with that is people don't really have an intuition for the uncertainty in the entire model. So we've changed it to now have uncertainty determination at 2 places in the analysis, one in your solution unit emissions, and the other would be in your market penetration, because these are the areas that users have the most insight into the uncertainty. So for solution unit emissions, the default is 25%, but you can modify this depending upon the maturity of your technology, how it's currently being scaled, known ranges of uncertainty, et cetera. And and then see a chart of your solution unit emissions. And then we've added some sanity checking throughout the analysis to help guide users to understand what the model is saying and how the different metrics are interacting with one another. So at this point, you are instructed to review your unit impact. And as a reminder, this is sort of the net benefit of implementing the solution. So in this case, it would be 0.15 to 0.14 million metric tons carbon dioxide equivalents per megaton cement. And as a reminder, we have selected these settings. So the sales units in megatons of cement, this would be for greener clinker production enabled cement versus global cement production. And I don't have a sense looking at these numbers myself if this is reasonable. So what I did was a quick Google search to check this. And this is what I would encourage all users to do. Make sure the data is aligned with your expectations and the most current values as well, because some of these might be using data that's 5-10 years old and the market could have changed. So for checking this, what I did was I looked at the references in the report and I saw that they used the IEA 2017 ETP data set without wanting to go find it and download it. I just Googled cement industry emissions, IEA, and I see their 2023 report comes right up and there's this chart there. And I can see that the baseline intensity is around 0.48. And then looking at the study that was also referenced in the model, I see that in the abstract, they say the greener clinker can have a 30% reduction in carbon emissions of cement manufacturing. And so on the right here, you can see I do some back of the envelope math and I say, okay, here would be the solution intensity if it had a 30% improvement. Here would be the unit impact, 0.14. That aligns really well with the unit impact that we're modeling here. So this seems reasonable to me. Of course, the big question as a user is the study for the 30% reduction a realistic proxy for the company or technology I'm modeling? And that's going to be up to the user to determine. If it's not, you can certainly change your solution emissions, change the reference. But it makes sense here if it was following the technology in that study. And while in the soft launch phase, you may need to click back and next to navigate between screens, see all the references, remind yourself of the numbers and units. That's the kind of feedback that will be really helpful from you all to know, like, if you were having to click back 3 pages because you needed to see something, but you wanted to see it on a different page, Cassie will integrate that feedback as we finalize the user experience. So please do take note of that. Once we have our unit impact established, it's a matter of determining the market size. So we'll start with the serviceable available market, and this is the applicable portion of the market that could be targeted by a technology. In this case, it's global cement production. And as I said, oops, this is actually on the wrong screen, sorry. You can modify your uncertainty now for your market penetration. So once you can enter your market penetration in your serviceable obtainable market screen, which comes after the baseline market size. So this would be the portion of the market that you expect to be able to capture. And you can either enter a sales forecast and have your uncertainty here, and that would be a company projection for modeling planned impact. Or if you don't have a sales forecast and just want to look at what if I captured a certain percent of the total available market, you can do a technology projection, and you would toggle at the top here to go between the two. So if you go to a technology projection, that will take you to the S-curve calculator, where we have some defaults for different S-curve speeds. We have accelerated, standard, and slower. This will just change the takeover and hypergrowth parameters of the S-curve. They don't necessarily reflect any specific market deployment, but it's a way to kind of get you started with looking at different S-curves here. And the takeover rate, hypergrowth rate, these are in years. The saturation is 0 to 1, so 1 being 100%. So in this case, we're modeling 100% saturation by around 2030. Very high market penetration, but that's what we're showing in this demo here. And once you set your market penetration, you're ready to look at the results. And so we've redone the results screen to more closely align with what you saw while setting up the analysis and the metrics that you are familiar with from Project Frame. So you'll have a table at the top that has your unit impact and your obtainable market size. And if you multiply those two, you get your annual impact. You can also download at the top the Crane input file as well as the Excel workbook, and I'll show you what those look like in a moment here. And then you have your graphs. So in this case, we have our annual impact, our cumulative impact, and I always encourage users to contextualize this and see if it makes sense. So if we go back to that graph I showed you earlier of the IEA cement production emissions, we can see that all cement emissions globally in 2022 were around 2,400 million metric tons. And this reduction potential represents around 25% of all cement emissions today by 2040. So we have to ask ourselves, does that make sense? And the answer is it does here because we set such a high market penetration. We said we'll take over 100% of the market by 2034. So if we have a 30% decrease in technology intensity, it makes sense that we have this significant emissions reduction potential, but it doesn't actually represent a very realistic technology penetration. So there's work to be done here to improve the feasibility of the model, I would say. The other thing I want to call out is the unit impact has quite a spread of values. So it goes from almost having no benefit to being extremely beneficial. And that's because we had a pretty high uncertainty entered for the solution GHG intensity. So I would then improve the accuracy of the model by clicking back and changing some of the parameters. So we know that the obtainable market size was unrealistically large. So I could change 1 to be, say, 0.1 and assume we take over 10% of the market by 2034. That seems more reasonable. And the unit impact uncertainty was 25%, but in the study, it was much closer to 10%. So we can lower that and then see the refined analysis results where the potential impact is now 63 rather than like 600. That seems a lot more probable. And that would assume that the technology is adopted by 10% of the globe. And then the unit impact range has been tightened because we lowered the uncertainty to more closely reflect the technology as we expect it to be deployed. So, you know, that you can change these values to your heart's content, but this is an example of how I would do it to try to make it a little bit more accurate. And then once we're satisfied with the analysis, we can export our results. So you can export it as an Excel workbook where you have a table of all the key metrics, including your market sizes, your solution and incumbent emissions intensities, and your unit impact. Then you can also export the Crane input file, which is a JSON file. This is great because then you can just drag and drop it onto the home landing page in the future if you want to quickly reload the analysis.